So we'll be looking at these applications today, but before then, we'll still practice more on our minimum and maximum using what we have done, but these are application problems. Some of them I got from your textbook, some of them I got from other sources. In fact, the first 5 questions, actually the first 7 questions are from my Form 4 calculus class, because I gave them a taster of what differential calculus is about a few months ago, and we use this. So I thought we'll also be able to make use of it in this class. Anyway, so I'll be sharing this with you today. The rest I would not be sharing. I wouldn't be sharing typing out the textbook, like I said, because there's so many concepts. I'll probably just share the book with you right here. Okay. So let's get right to it. Let me see what programs I can close. Sorry, I have too many programs open, so I'm trying to close some of them. Okay, I think I'm good now. Almost good. Okay. Let's open the textbook, and can somebody remind me the last question that we practiced the last time? Anyone, please? What was the last exercise that we practiced?
14B2.
14B2, okay. So this set of questions, yeah?
We did up to 2.
Yeah, oh yeah, I think I did one, then I asked you to do one. Is that true? Did I send you a screenshot of this already?
Yeah.
Okay. I hope some of you practiced or you did not. If you practice, raise your hand. If you practice something on your own, don't be shy, tell me the truth. Did you practice anything? Anyone? No one is talking. Okay, Crystal, did you practice? Crystal K, let's start with you. Did you practice any of them?
No.
No? Okay, I'm coming for you. Mr. Chang?
I was too busy working on my economics.
Nice excuse. Leo, how about you?
I didn't.
Big trouble for everybody. Lillian? Lillian? No. C? Krista C? Can Krista hear me?
Yes.
Okay.
But I didn't practice.
Why? How about you, Clarissa?
I didn't practice the one you gave.
Okay, but you practiced some other ones or what?
Yeah, I watched a video.
Oh, okay. Okay, Miss V, what up? Did you practice?
I just finished the one I was working in class. Like I wasn't able to complete
Okay.
it. I just finished it.
I'll tell you why I'm asking this. So I'm gonna ask Nakita, how about you? Any practice?
I only did G and L.
G and
L.
L. Okay, Miss Karen. Oh, Miss K. We agreed it's gonna be Miss K.
I didn't practice.
Oh no, why not? Callista, don't tell me your cat didn't let you practice. What happened? No. Mr. B, apart from the drinks, what else have you been doing?
Sleeping.
Oh God. Okay, so this is the reason I'm asking if you guys practice or not, because remember, practice the same make perfection. Even if I do not give you work to practice and you have the screenshot sent to you, just attempt 1 or 2 questions based on what we did in the class. That will be enough for me. But sometimes when you do not open those materials before the next lesson, it's somehow difficult sometimes to connect what you have done before with what is about to be done. Okay, so that's my main worry, nothing more. So I know you are busy with other things. You have extended essay, you have economics, you have science, you have this. So I would be, let me say, I would be selfish to expect you to focus all your time on mathematics. That would be selfish. Okay, so I know you have other things that you need to commit yourself to, apart from normal teenager stuff, whatever that is anyway. So please, just take some time, get a schedule, like a weekly schedule. I was talking to one of you about scheduling in the past, a couple of weeks ago. Get a schedule. Okay, Monday I want to practice this, Tuesday I want to practice that. And this is what I like to do. If I have a subject tomorrow in a class, because I know the teacher might need to link it, I make sure that at least I have a practice time today before that class. Okay, so my class is tomorrow. If I hadn't, scheduled that practice for weekend, I schedule it for Wednesday because I know I'm seeing that person on Thursday. So when I revise again on Wednesday, then I'm able to answer any question and connect that activity to what has been taught in the past. Then my teacher will not feel disappointed or feel that, oh, I've just been wasting my time all along. So let's check that. Now, I believe we still remember what we did, but just to be sure, can we follow this instruction and attempt question 2D? Can everybody see this? Question 2D. And if you have done that 2D, please signify, then I can give you something else. Everybody, 2D. So I'll leave the example also on the screen, just in case anyone needs to look through that. Can everybody see the textbook clearly? All right, so let's go to 2D, people. So let's take 5 minutes if possible. Try to be as fast as you can so we can move into other stuff. Thank you. While I do what Brandy did by getting a drink for myself alone, that's what he did. Mr. B, it's my turn to get something for myself alone. Oh no, you see what this dude is doing? He's showing us. But I can get for Crystal K. Only. Crystal C, I can only see 20% of your face. What's going on? Okay, that's much better. Because the forehead doesn't have your smile, and I care about the smile. Camera is on there. Right. So your answer is still correct. Let's see. So I'm looking at your completing the square aspect. Yeah, yep. That's correct. That's good. Krista C, checking now. Well done. Now you can have some ice cream. Mr. Chang. Lazy man. You wrote, after you're completing the square, Mr. Chang, you wrote vertex is 1,2. Ow. So you couldn't write. Show me how you got your 1 and how you got your 2. Lazy dude. All right.
Wait, do I have to write from a bracket x minus?
Yeah,
H.
right. You're just being lazy.
Oh, okay, I'll do that next time.
Okay. Axis of symmetry, Nakita, is not, don't write just 1. It's x is equal to 1. It's an equation, remember?
Okay.
Okay, so that's all about it. Every other thing looks good. And your graph looks like a V shape. Maybe because on my screen, you're close to V now. Actually, you guys are together on my screen. So is that why you use a V shape? Just kidding. Okay, everybody looks okay. Lillian checked. Venna checked. Okay, where are the others, please? Miss K, Kalisa, Mr. Leo. Did I see Krista K already? No. Actually, I have 2 Miss K in the class. So anyway, Karen will take Miss K. You will take Mr. Krista K. We don't want confusion in the class. So I haven't got yours too.
I feel like I got something wrong.
Okay, so while we are waiting for the rest of the class, we'll be looking at this next. Please look through this notes for those of you that are done. Look through this, see if you can understand the idea, because the next thing we will do is this, okay? So look through this note first. Okay, Karen got your work, checking now. So Karen, I've seen your work. Correct. Good job. Leo, checking. Leo, something is wrong.
Yeah, I know.
Something is wrong somewhere. So can I quickly check for the last 2? So I know how many people need the correction. Then I can talk to you about this. Crystal. Okay, so Crystal K, you decide to put your brackets, the constant term, you decide to put it in the bracket during your factorization. You got it right, but you could leave it outside also. That might be easier for you next time. Can you hear me?
Yes.
Okay, that might be easier next time, but you got it right. So let's see, Clary. Yeah, Clarissa did the same. So Clarissa, did you hear what I just told Krista? So you might want to leave 5 out of your factorization because your 5 is also factorized. So you got 5/3 from your line 2. That 5 could be left alone, okay? So that's the only thing. So Leo, please come with me to the board. If anybody needs this, maybe I take a picture of this and send to the group. Please, this is what we are doing next. I send it to our WeChat now. Because I'm going to be sharing okay. So you can write some notes, jot some important points for yourself from the screenshot that I've sent to the group, and I'm sending the example as well. So Leo, can you see the board?
Yes.
All right, so let's do this together. Okay. So can you give me the equation? Y equals what?
3x squared.
I'm going to write the date first. It's Wednesday, 1st April. Happy New Month, by the way, everybody. So we're still on quadratic sketching. Okay, so y equals, yes?
3x squared
Mm-hmm.
minus 6x plus 5.
Good. So this is what I was telling Clarissa and others. Keep this guy out of your problem for now. Okay, so this will be 3 brackets x squared minus 6x. No.
No, because I roll like 6x divided by 3 inside.
Oh, okay. Yes, perfect. You're right. You're right. Let's do that. Like that?
Yeah, I did like that.
Yeah, that's better. So you don't get confused if you're used to that. Then you have this, right?
Yes.
Good. Now, 3
Bracket
brackets. A
x
lot of
squared.
things happen in this bracket. Then I have my plus 5. Okay. In the bracket, I have x squared minus 2x. Now, to complete the square, I'm going to have to add something, and I have to subtract that thing. So you could see that all my addition and subtraction is being done on these two, isn't it?
Yes.
It's inside the bracket. Right? So everything must still be contained inside the bracket. So what are we adding? You got that right. Is -1 squared. -1 squared. The only problem with your workings is this. You close the bracket and this other part was outside the bracket. Did you see that?
Yes.
So it is not meant to be, because you're actually doing something with these two and they are in the bracket. So whatever operation you are performing on them stays within the same bracket. It doesn't have anything to do with this. This 5 plus 5 is the only one standing alone. Does that make sense?
Yes.
So this part of it now makes everything become 3. Then you have
X.
can you see my bracket is still there?
Yeah.
Then that will be x minus 1 all squared. This bracket is what I had written as this. Do you prefer this, or I can just make it bigger?
It's okay. It's okay.
Anyone is fine?
Yeah.
Okay, good. So the part that I underline in brown, I've written in brown. This minus remains there. Now, -1 square is +1. Because this minus vanishes, right? Then I have closing the brackets plus 5. So I'm done with the factorization. So all I need to do now is open this bracket. So 3 will multiply this and 3 will multiply that. Can you see? So when 3 multiplies the first one, I have this. Then when 3 multiplies the second one, I have that. And this guy was just minding his business or her business all along.
Oh, that's why.
That's why you got it wrong. So x minus 1 squared plus 2. Okay.
Okay.
And after this, the next thing is to what? You've just found, you can get the value of x at the vertex.
And then find the y-intercept.
Find the y at the vertex. So at the vertex, x minus 1 is equal to 0, which means x is equal to 1. And at the vertex also, y is equal to 2. This.
Yeah.
Okay. So equation at the vertex, the coordinate of the vertex is 1, 2. The next thing is to find the y-intercept. At x is equal to 0, can use the equation because all this will become 0. At x equal to 0, y is 3x squared minus 6x plus 5. That will be 0 minus 0 plus 5, which is equal to 5. So your y-intercept is y is equal to 5. Okay, so we have the vertex, we have the intercept, and since a is greater than 0, a is this. Okay, I'll color code that. This is my a, so this is a. So since a is greater than 0, then the curve is minimum, right? It's of minimum.
Yes.
So now that we know it's minimum, you draw a curve that looks like minimum. This vertex gives you your axis of symmetry, x is equal to 1. So that's your axis of symmetry. It will be a broken line, right? So that's equal to 1. The coordinate at that point, we know that the coordinate at that point is this.
1, 2.
1, 2. The y-intercept is 5, which is this one. So when I draw my xy coordinate, now this is y equals 2. Y equals 5 will be above, right? But that is when x is 0. So this is x is 1. X is 0 will be behind it. If this was x is negative 1, x is equal to 0 will be here. Agreed?
Yes.
So, which means my y-intercept will be here. Somewhere here. Okay, I just do this. I use this instead. Does this make sense? So, I use point. Y-intercept is 5. Now, this is y equals 2. So my x equals 0. Actually, I like to use the arrow instead. Okay. So my x-axis will be in this form. As long as it doesn't touch the graph. You label properly. Y-axis, x-axis, and that's it. Okay, so this is what everyone has been asked to do. Good job, everybody. Oh, Callista, sorry, I just saw your work. That's good. Good job. All right, so please take note of this, Leo. So let's move on. Look at what I've sent you. So we have another way of sketching. You see, it depends on the situation you find yourself, right? The root of an equation is given by the quadratic formula. Can I ask the class, does everybody understand the screenshot that I sent to you, or do you need me to explain it? If you need me to explain it, raise your hand. Okay, apart from Leo, of course, because Leo was busy with me. Everybody else understands it? Okay. Karen, how about you? I didn't get any message. Okay, good. So especially because of Leo who was working with me, so I'm going to just go through it here. So please, Leo, make sure you write some things from here. If you want to sketch of this form, now we have learned that you can actually put it in this form, because this form is also in this form as also, okay? Talk to me, Leo, I'm talking to you especially.
Yes.
All right, just nod your head or you talk, so I need some gesture. So we can either put it in using completing the square, find the vertex, find the intercept, and so on and so forth. So, but this is another way to do it. If you want to graph this directly without first converting it in different form, you see it says without taking it to completing the square form. We know the solution is this. You know how this came about? Leo, that's quadratic formula, right? We know that the solution is this. 1 is plus, 1 is minus, okay? So where this is this. Now, if this is greater than 0, discriminant, I believe we have done discriminant. Was it this class or the other class? If discriminant is greater than 0, you know that you have different values. That's distinct roots, okay? So in that case, it will be in this form where it intersects. I go to the board. I'll show you something on the board now. And I think everybody might need to listen to that. Sketching y equals ax squared plus bx plus c. So without changing to different forms. If you have taken any notes from the book, you don't have to write what I'm putting on the board. You could just pick any point that you see that was not taken note of. Without changing into any form, okay, we can still sketch. Now, so what the note is trying to say is that from y equals ax squared plus bx plus c equals to 0, using quadratic formula, x is minus b plus or minus root b squared minus 4ac divided by 2a. That's what it's saying, which was summarized as minus b plus or minus square root of delta. That's a discriminant divided by 2a, where delta is b squared minus 4ac, which is your discriminant. Now, these are the cases that we have. If delta, that's not delta. If delta is greater than or equal to 0, or let's put it in three form. If delta is greater than 0, we have distinct roots, which means we can either have this or this, and x-axis crossing them, two different forms. That's what the first point is about. Another thing that the note is trying to tell us If delta is equal to 0, we have equal roots. Implication of that on the graph is this. It means whether you have maximum or minimum, minimum or maximum, this is what you have. It touches the x-axis at that one point. That's what equal root does. Okay? And the third case of the discriminant, if delta is less than 0, we already know this. We have complex roots. I believe everybody knows this. Talk to me, guys. You know about discriminants, right? Aha, so that's why I'm not wasting time asking you those questions. So we have complex roots. We have complex. How do you know you have a complex root in the graph? Anyone? It doesn't touch the x-axis at all. It doesn't touch the x-axis. That's how you know you have complex roots. So this could be your x-axis and it doesn't touch it. This could be your x-axis and it doesn't touch it. That's how you know you have complex roots. And draw them properly. The OCD in me. Arrow means it extends indefinitely. So that's why the arrow is usually being used. It means it extends indefinitely on both sides. And that's what the axis tend to do. So x-axis, x-axis in any case. No, the last two, rubbish. It doesn't touch it. That's the point. Sorry about that. So this looks this way, and that looks, it never touches the x-axis. That's the whole point. Okay. Now, in the first case where it touches it, we can still get our axis of symmetry. How is that? So I share with you the screen again. So if you have different roots, the axis of symmetry will be the midpoint of these values of x. We've mentioned this in one of the previous idea also. So when you add this and divide by 2, you get your axis of symmetry. And if you, then the vertex will be, the vertex has this x coordinates, and that is the equation of the axis of symmetry. That's what this is about. For those that might be wondering what I just said, so for the first case, of delta greater than 0, let's say we have the x and y axis, this. I'll just make a small sketch, please. And we have our graph. Now, this is x1, and this is x2. The axis of symmetry is the midpoint of x1 and x2 because this axis of symmetry is the point where you have the same thing on both sides. Does that make sense? So that makes this, whatever value of x you have here as the midpoint. So x in this case is the midpoint of x1 and x2. So this x is actually x1 plus x2 divided by 2. Okay, so that's what we'll explain in the book. Now from this, from x equals minus b plus or minus square root of that delta, not d. You can use d, doesn't matter. Our x1 is minus b plus square root of delta. And our x2 is minus b minus square root of delta. So if you had, no, divided by 2a, not divided by 2, apologies. If you add this to get this coordinate, this x is just the quadratic formula, please. The x in this place is talking about the value of x we have here. Okay, so maybe I can use different notation. I can call this x naught. I can call it, so you don't mix them up. Okay, so having said that, from x naught equals x1 plus x2 divided by 2, because that comes as a fraction, I can write it as this. Agreed? So let's substitute x1 and x2. This is x1, this is x2. We substitute. So it means our x naught, remember x naught is the coordinate of x at the vertex. This is x naught. Okay? All right, so x naught will be half into, so we can use a bigger bracket. So x1 minus b plus square root of delta divided by 2, x2 minus b minus square root of delta divided by 2. So that will be half, and I can open the bracket, plus times this doesn't change anything. And I have my 2 as the LCM, so I get minus b plus root delta minus b minus root delta divided by 2a. Why do I keep writing divided by 2? So at the end, you get this. Minus delta and plus delta cross out. So you get minus 2b divided by 2a, which is 1 over 2 divided by minus b over a. And it means that our x naught, which implies that our x naught is what? Minus b divided by 2a. And this is what you have seen in the book. So it means if you have this is 4, this is 3, no, that can't be 3, this is 13. What we are saying here, this x naught, that's the value of x here, is this point. Do you agree? And that is simply 4 plus 13 divided by 2. Divided by 2. Because I'm not talking about 2a now. I'm talking about this and this. That's what we did here. That's what this is about. Okay? The first one, the second one divided by 2. That's what this is about. Okay? And that will be 17 divided by 2, 8.5. So this equation of the axis of symmetry is x equals 8.5. But you don't have to get this solution to know. So from the equation itself, so if you get y equals, let's take a sample. From the equation itself, y equals, this equation 3, let's use something easier for me to quickly figure out the answer. Y equals x squared minus 5x minus 6. If you solve this, you're going to be getting x minus, yeah, x minus 1, no, x plus 1, x minus 6. Do you agree? So the answers will be, I need the class to confirm. Do you agree with this? So it means x1 is -1 and x2 is equal to 6, right? It's a maximum problem, a minimum problem, so it's going to look this way. And the intercept will be -1 and 6, which means the axis of symmetry is 2.5. So this will be x is equal to 2.5. And the y-intercept is -6, right? So it means if I want to draw my, okay, I take this off, I always draw my axis in red. So that's my x-axis. My y-axis is -6. So my y-axis is when x is 0. When x is 0 is closer to this, right? Aha. So when x is 0, it look like that. Okay. So that's what I have then. And it makes so much sense. As you can see, it crosses here at -6 below it. Because if you put x is equal to 0, you get y is -6. Does that make sense? If you put x equal to 0, you get y is -6. Now, what does this mean? How is this connected to what we have said here? What this means is that with just your ax squared plus bx plus c from y equals the original question, my a is what? 1, b -5, c -6. If I find minus b divided by 2a, what is minus b? That's -5 divided by 2 times 1. I get my 2.5 directly from the equation. I don't have to solve it and then find the midpoint to get this 2.5. That's the point here. Does this make sense, everybody? So I don't have to start solving. What if the equation is so complicated? What if the equation is in fraction form? I mean, the coefficient are in fraction form. Then I have to go through different, I can't do the factorization directly. I need to find 2 factors and all those kind of nonsense. So what we are trying to say here is using minus b divided by 2a, you can directly get your axis of symmetry. And we all know the moment you know your axis of symmetry, the rest is easy. Do you agree? The moment you know your axis of symmetry, the rest is easy. Because that's the purpose here, that's the main point here also. We're trying to find the vertex, which is where the axis of symmetry is. And of course, when you know that your x is 2.5, you can easily get your y. So you get the coordinate of the vertex. Remember, x is 2.5 is the value of x at the vertex, right? And that can lead to the value of y at the vertex by mere substitution into the original problem. So we're actually doing the same thing that we did in the previous one, except that we are not going through this procedure to get the vertex this time. So it's the same. The only thing that is being replaced is this. Okay? Get the vertex, get the value of x in the vertex by using substituting minus b over 2a. Once you get that, substitute to get the value of y at the vertex. Now in this case, it is easy to get y at the vertex because this is the one that stands alone all the time. In the new case, you have to substitute to get it. But of course, in the new case, you just have to substitute a, b, c. You don't have to go through all this mess. Am I making sense, please? Okay, so the only thing that is different is this, like I said, every other thing remains the same. Get your vertex, get your intersect, and sketch, and that's all. This is especially if you check your discriminant and your discriminant is greater than 0. If your discriminant isn't greater than 0, you don't have to waste your time. You all know your vertex is that value. So if your discriminant is equal to 0, for example, what happens? Let's see, let's follow the same thing. If my discriminant is 0, then this doesn't happen. Okay? You agree? This is 0, this is 0. So it doesn't even occur. It means I still have to go about this. Am I making sense? Okay, maybe that's not clear. Remember, my x0 is x1 divided by plus x2 divided by 2, right? So my x0 is going to be half of x1 plus x2. But in this case, my x1 is minus b over 2a. My x2 is minus b over 2a. Because they are the same. I got this from minus b plus or minus square root of delta divided by 2a. If delta is equal to 0, this plus or minus doesn't occur. That's the purpose of equal roots. x1 and x2 are the same. What is the midpoint of the same number? Isn't it the same thing? You are looking for the midpoint of 3 and 3. There's no midpoint because there's no gap in between them. So at the end, you still get your midpoint as the value. So which means it's still the same thing. Does it make sense? Which means it's still the same thing. All right? We can apply this also to complex roots. When they are discriminant, so maybe we write that as just part of the notes. But in general, we are just using the b over 2a, all right? We are using the b over 2a. For those of you that know that sum of roots is minus b over 2a, minus b over a, this should be easier for you. If you have quadratic equation, if you solve, the sum of roots is minus b over a, product is c over a. Anyway, we'll be doing alpha and beta and whatever later, so let's not deviate. So I just want to add more to this for the case of that. And similarly, if delta is equal to 0, the only thing is that x1 and x2 is minus b plus or minus 0 divided by 2a, which is minus b over 2a. So since they are equal, there's no midpoint. Okay? Talk about midpoints. In fact, when you sketch, it actually touches at the solution, isn't it? And it turns at the solution. Okay? Make sense? So what we mean is that at vertex, our x0 is the same as x1 or x2, which is minus b over 2a. I write it on different line. Which is the same thing with the other one. Is it done now? Okay. No, I'm almost done. And similarly, if you have complex roots, do you remember when we started complex number? Do you remember the video that I showed you? It doesn't cross on the real line, but it crosses in another dimension, right? So even if you have complex root, the same thing will follow. So let's write. If your delta is less than 0, which is the case of complex roots, we still have our roots to be 1 and 2. The only thing is that x1 is in form of I. The x2 is also in form of I. but there are still x1 and x2. Do you agree with me? So it's still the same, it's still going to go through with this process. It's exactly this one. Okay? So we are still going to do this calculation. All right? In case you have complex roots. Because for complex root, you'll be having maybe 3 plus 2i and 3 minus 2i. What it means is that they are distinct. We never said here that they are distinct and real. Does that make sense? Aha. So I won't be writing anything. I will say if this happens, it is exactly as delta is greater than 0. So our x naught is x1 plus x2 divided by 2, and it's still minus b divided by 2a. So in any case, it is minus b divided by 2a. That is why in the screenshot that I sent you, the 3 cases were not considered, because everything comes back to the same thing. So this is why everything comes back. I hope you understand what I mean in the case of complex roots, please. So if you have complex roots, even though it doesn't cross the x-axis, it might touch the y-axis, but if you look at that video, something pulls it to the 3rd dimension. You remember that video on complex number? So at the 3rd dimension, it is symmetric as well, about that axis of symmetry. Please confirm if you understand what I mean, please. Does everybody understand what I mean? Aha. So it doesn't touch in the real axis. Okay. So let's see. Let's go back. So I'm going to show you quickly an example, the screenshot I've sent to you, so you can write the example in your notes, and let's see quickly. So this is an example. Okay. The first question is to find the axis of symmetry. Very easy. From your equation, identify your A, B, and C. Okay? Since A is greater than 0, the shape will be the minimum. Take note of that. Then from your A, B, and C, work out minus B divided by 2A. Okay? So, and that is -2. So the axis of symmetry is an equation x equals -2. From your x equals -2, find the y-intercept. That's why it was numbered, labeled that way, A first, B, C, D. So these are the process you follow. Okay? So find the y coordinate of the vertex by substitution. That's all. So substitute into the original equation, you got this. So the vertex is this. The next is to find the y-intercept. Y-intercept is when x is equal to 0. Okay? Now, if you look at this, the intercept was also found because this is the case of distinct roots. But if it is a sketch and I do not, you don't have, okay, say find the intercept. Well, that is why this is necessary. Okay? Do you understand my point? But without that, we can actually just have a sketch with this and know what the shape looks like. But because your sketch is more meaningful with the intercept, solve the equation equal to 0, you get this 2, so you know where it crosses the x-axis. Okay? And with that, you know your y-axis, you know your x-axis, you know your vertex, then you're good to go with the sketch. Any questions, please? Okay, so you have the screenshot of this. Am I right? Did I send this to the group? Okay, so write this as an example in your notebook that you can refer to at any time, and the sketch. Then I will send this to you, and this will be, unfortunately, I thought we would do that word problem, but unfortunately we can't. Let's see, because of my time. I send this exercise now. There is another one. It continues on this page. So I'll pick some of them now because I may forget later if I want to wait till later. So for the first question, do questions, let's see. One A, no, one, yes, 1A, 1D, 1I. 1A, D, and I. Of course, you can practice more than that on your own, I will advise. So for question 2, practice 1, D, B, let's start with 2B, let's pick B, 2B, 2C, because it looks like a binomial, but it's not binomial. 2B, 2C, 2F, and 2I. Okay. Does everybody get that? So let's practice this. When we meet on Friday, then we can start looking at the applications. Okay. Let me see if there are word problems in the textbook also, because after this, see, these are use discriminant to find which shape, blah, blah, blah. I'll probably send this to you. With the problem I have with this 1 hour thing. So find the equation from the graph. We should look at that also. Can you see my screen? Oh, I'm not sharing my book with you. Can you see the book? No? Uh-oh, sorry. So there are other things, like I said, you see, finding the equation from the graph, we look at that. So I don't think we can start the word problem immediately because I don't want to leave any stone unturned. I really want us to rush through with this. Friday, if you don't mind, we need to find maybe like maybe some extra 30 minutes, if that's okay, because we are postponing this thing too much. And I don't want us to spend too much time on this function. So it would be nice if you practice and if you can, sometimes when you're practicing in the class, then the time is gone, everyone is trying to work. It doesn't really help us. So if we are not too busy on Friday, I'd like to maybe extend like 30 minutes more beyond our normal time. So please let me know before then if that is going to affect any plan that anyone has. Otherwise, then we can. So please get in touch with me privately if you have something doing. Otherwise, the class will extend beyond 30 minutes on Friday. Let's see how much of this we can cover because I need us to really go through with the application. The applications are also in your book. I got some questions from your book, like I told you. I'll show you quickly. Blah, 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 blah. You see, it's a huge topic. You see, these are some applications to word problems, then the application to optimization. But that's what I want to go to first because we are dealing with vertex. That's the maximum and minimum. So that's why I want to bring that in. And maybe we bring that in before we start going into other nature of the graph. I will decide whatever we need to do before Friday. Okay? Any questions, please? Before we go? No questions? All right, I'll see you all on Friday. Please practice what I've sent you and more. See you. Have a nice time.
Bye.
Bye.